Okay. Hello, everybody. Today we'll finish chapter 2, the discrete probability. We'll talk about geometric distribution, exponential distribution, and Poisson distribution, or fish. Geometric distribution is a discrete probability distribution of a random variable x that satisfies the following conditions. A trial is repeated until a success occurs. The repeated trials are independent of each other. The probability of a success, P, is constant for each trial. Here with repetition. We have repetition here. Okay, replacement with the replacement. The probability that the first success will occur on trial X with Q equal 1 minus P is probability no success, no success, no success, no success, till we have success. So it's X minus 1, no success, then at X we have success. And we'll stop here. So the probability of X in geometric distribution will be equal P times Q power X minus 1. Okay, example. A fast food chain puts a winning game piece on every 5th package of French fries. Okay? Find the probability that you will win a prize. In Arabic, محل أكل عم بربح جائزة كل 5 علب بطاطا. بين كل 5 علب بطاطا في علبة فيها جائزة. Okay. Find the probability that you will win a prize with your third purchase of French fries. هون here X equal 3. At 3 we will win. So first P equal 1 over 5, 0.2. جائزة ضمن 5 علب. So 1 over 5 equal 0.2. Q is the opposite, 0.8. For part A, X equal 3. So we put the formula P Q power X minus 1 to get 0. Around 13. Okay? Okay. Did you get it? With your third or fourth purchase of French fries. Okay? X equal 3 or 4. So P will be equal to probability of 3 plus probability of 4, which equal to 0.23. So we'll discuss this example. When the probability of X for X equal to 1 equal, P1 equal 0.2 and P3 equal 0.12. Why? Why P1 equal 0.2 and P3 equal 0.13, around 13? Answer. Probability to win price in the first package of French fries is P win. P win 1 over 5. And we have P no win equal 0.8. So in part A, to win in the third purchase of French fries, so we want to calculate the P no win, no win, win. This is 3 independent events, so we multiply their probabilities. So first, P no win equal 0.8, second times 0.8 times P win 0.2, that's why equal less than. That's why here 13%, here 20%. Because we add conditions, no win, and win. Okay? We don't have another combination like before. We don't do P no win, no win, or P win, no win. Okay? It's not combination. It's only geometric distribution. Okay? We calculated once. We have only one combination, is to win in the third purchase. Did you understand this? Did you understand? مريم؟
Yes, sir.
اوكي. مريم منانا كان عندك سؤال بهذا الموضوع، وضحت هلا؟
يا دكتور.
Okay. Okay. Let's continue. Exponential distribution. The most commonly used queuing models are based on the assumption. Focus on assumption. Okay. Of exponential distributed service type. Definition. The exponential distribution is a probability distribution of the time between event X, which occur continuously and independently at a constant average rate lambda. So, the probability density function PDF of an exponential distribution is fx function of time, lambda e power minus lambda t, when t positive or equal to 0, else 0. So, and the mean expected value equal 1 over lambda. Okay? So, from this equation, we can calculate cumulative distribution function, CDF. Of variable x is a function of x which tells you the probability that x is less than or equal to t. So, will be equal like that. fxt equal probability of x less than or equal to t equal 1 minus e power minus lambda t. Okay? So, the probability of x bigger than t, which equal the inverse, 1 minus above equal e minus lambda t. Okay? Focus on this equation, we'll use it. Probability of x bigger than t equal e power minus lambda t. Okay? Let's continue. The graph will be like this. For beginning of time, the probability will be the highest probability will be. With time, the probability will goes down. This modeling is good for duration of events, like in the queuing system, next lecture. So, the mean value here, the average value here, equal EX expected value or mean value or mu equal 1 over lambda. Okay? Example. We'll use exponential distribution in the lifetime of an electronic device. Like when you purchase a laptop or desktop or TV or whatever, for the first period of time, the lifetime will be high. Then, with time, needs maintenance, needs repairs, needs anything. Also, the time between arrivals of two successive buses. Also, the duration time of a car service. Time until next earthquake occurs. Okay. Example for that. The time we have, the time required to repair a machine is an exponential random variable with rate lambda equal half downs per hour. So, what is the probability that a repair time exceeded 2 hours? After 2 hours, what is the probability? Direct formula. Here, bigger than 2 hours, so the t equal 2 hours, okay? So for p, probability x greater than 2 equal directly the formula e power minus lambda t. Directly we put the values, lambda equal half and t equal 2, give us e power minus 1, 0.36. Okay? Direct formula. What is the probability that the repair time will take at least 4 hours? Given that, 4 hours, but given that the repairman has been working on the machine for 3 hours. So, probability of x greater than 4 over x bigger than or greater than 3 will be equal p x bigger than or greater than 1. So direct formula here, e power minus lambda t. So equal minus half, e power minus half equals 0.6. Okay? Do you have any question here? It's
ما
direct.
فهمت أنا تاني واحدة. فيك تعيدها بليز؟
السكند one تاني وحدة. Okay. هون what is the probability that the repair time will take at least 4 hours؟ عم يصلح سيارته بدها تصليح 4 ساعات. مع العلم given that مع العلم الريبير مان له عم بيشتغل 3 ساعات، يعني بعد ناقص له ساعة.
اوكي.
يعني 4 ساعات على 3 ساعات بتطرحهم بتعمل لهم ديفرنس so 1 hour. اوكي؟ يعني هالتصليح للسيارة بدها 4 ساعات بس مع العلم انه له 3 ساعات عم يشتغل، معناتها بعد له احتمال ساعة يخلص، عنده احتمال بعد ساعة يخلص، تطرحهم من بعض 4 minus 3 4 minus 3. اوكي؟
مش بيكون تعب بهالثلاث ساعات؟
سوري ما سمعت.
بيكون هو تعب بهالثلاث ساعات مش البرفورمانس تاعه حيقل؟
صح، مشان هيك قال لك. مشان هيك قال.
اوكي.
اوكي؟ يلا. تنفوت بواسون، هون بدي بطئ شوي. I will slow here. Poisson distribution or poisson, it's a French word, means fish. Okay? Poisson يعني سمكة, fish. The Poisson distribution is a discrete probability distribution of a random variable x that satisfies the following conditions. The experiment consists of counting. هون في عم نعد. Counting the number of times an event x occur in a given interval. The interval can be interval of time, area, or volume. Okay? The probability of the event occurring is the same for each interval. Always the same. So with the replacement, the number of occurrence in one interval is independent of the number of occurrence in other intervals. Each interval is independent. Okay? When we use this, the most commonly used queuing models are based on the assumption of Poisson distributed arrival times for customers. In the queuing system, we have customers, we have queue list, and we have server. Okay? The customers will arrive at lambda rate, at Poisson distribution. Okay? So the equation will be the probability of exactly x occurrence in an interval is probability of x equal lambda power x e power minus lambda over x factorial. Factorial. So where e equal 2.7, 2 or what else, and lambda equal mu. Here lambda it's the average or the mean number of occurrence. Okay? Example. The mean number of power outages in the city of Beirut is 4 per day. Find the probability that in a given day, how the mean number, the average number of turn off the electricity, power outage, turn off the electricity in the Beirut is 4 times per day. What is the probability if there are exactly 3 outages? Okay. So, if there are more than 3, okay. For part A, mu or lambda is the same here. Mu, the mean value, the mean number, the expected value. Mu equal lambda equal 4 times per day. X here in this part A will be equal to 3. So direct implement your equation directly gives us 0.19. Okay. Whereas there are more than part B, for part B. Any question for part A? Any question?
No.
Okay, direct implementation of the formula. Part B, there are more than 3 outages. So P probability more than 3 will be equal, opposite than 1 minus P less than 3. So will be 1 minus P3, P2, P1, P0 plus. Okay, we add them. So using the same equation above to calculate P3, P2, P1, and P0, then the probability will be greater, 0.56. Greater. Why it's greater? Because more than 3. More than 3. Okay? We have here or pluses. Okay? Any question here? Good. If we choose different values of lambda or mu, the graph will be like this. If lambda equals 0.1, very small, so 0 will be 0.9 and 1 would be 0.1 to sum them to get 1. هون بنجمع البروبابيلتي اللي يطلع 1. اوكي ف 0.9 plus 0.1 equal to 1 and the others is zeros. Here for lambda equal to, so the probability of 0 will be around 0.18, 1 and 2 around 0.3, 0.3 x equal 3 around 0.2, 0.15 and other zeros. Sum of this will be equal to 1. Or if lambda equal to 5, the average 5, so will be the maximum at 5 here increasing then decreasing. If we sum all of this must be equal to 1. Okay? Example. It's an important example here. Customers arrive at a restaurant according to a Poisson distribution at a rate of 20 customers per hour. We have lambda here, 20 customers per hour. The restaurant opens for business at 11 a.m. So, what is the probability of having 20 customers in the restaurant at time 11:12 a.m. after 12 minutes? But given that there were 18 customers at 11:07 a.m. So, what is the probability of having 20 customers at specific time, 11:12? Given that they were 18 customers at 11:07 minutes. So here we must draw the timeline. Solution. Lambda equal 20 customers per hour. We can write it as 20t. T in hours. Okay. If t equal 1 equal 20. Okay. It's average or mean number. So assume NT be the number of customers arrived during T hours. Okay. So PK, K is NT equal K for K customers equal lambda. Here is we have lambda 20T power K over K factorial E power minus lambda T for K equals 0, whatever. So in this example, what is the probability that 20 customers in restaurant will be at 11:12 given that there were 18 customers at 11:07 a.m. So we draw the line. We have before 11:07, okay, we have 18 customers. So we want to calculate the probability from 11.7 to 11:12, new event here, independent events here, okay? An extra 2 customers to be 20. So we make the difference here. So the total number of customers between 11:12 will be equal 20, such that from 11 to 11.7 equal 18. So 20 minus 18, like before. 20 minus 18. So we need only 2 customers in this period of time. We need only to calculate the probability of two customers between 0.7 and 12. So the probability of 5 minutes, here we have only in 5 minutes, we must calculate two customers. What is the probability to enter two new customers in these 5 minutes? In these 5 minutes, okay? So we have here the time, we have the t. We have t here, 5 minutes. But the t unit here in hours. In our system, the t is an hours. So we convert minutes to hours. So will be equal lambda 20, t 5/16, because minutes to hours, power 2, why 2? Because k equal 2 here, x equal to 2 here, okay? E power minus 20, 5/16 over 2 factorial, because k equal 2 here, equal 0.26. Okay, any question for this slide?
بركي شو اسمه سألونا إنه خفوا الكاستمر مش زادوا.
السؤال هون قال لك the question is بده 20 what is the probability to get 20 customers in at time 11-12. اوكي عندك 18 عندك 18 you have 18 you miss only you need only new customers only two customers to get to 20. هذا السؤال ل 20 اوكي هذا السؤال.
بس بركي إنه سألونا إنه ل 16 إذا بركي إنه خف العدد مش زاد، شو بنعمل إذا خف؟
ما فيك تعمل هيك، ما فيك تعمل هيك. بطلت عم تشتغل على بوسون، بطلت عم تشتغل على الرايفل، انت هون عم بفلوا صرت بكيونج سيستم انه ظهر اثنين بتحلها بمحل ثاني ليتر اون حنحلهم ليتر اون بكيونج سيستم حنشتغل عليه يعني كيونج سيستم اوكي. لانه بهالحاله سبك تحسب كاستمر ارايفل تايم يلي هلا بنحسبها بلس كيوينج تايم ليتر اون حنشوفها بالكيوينج سيستم then server time to serve the customer. You have three different stage in the queuing system. Arrival customers, queuing time list, okay, then server time to get out. إذا أنت بتقصهم من 20 أو من 18 ل 16 يعني ظهر اثنين ما في نحسبهم الأرايفل. هون عم نحسب arrival فقط. إذا لاحظت هون لاحظوا شو السؤال. Customers arrive على arrival okay. هون the probability of having customer in the restaurant having يعني arrive اجى 20 ما ظهر. هون كله السؤال على arrival time اوكي. later on حنشوف لما exit حنشوف مثل جراف حنرسم الجراف مثله في input و output ونحسب الديفرنس we calculate the difference. yes اذا نفس السؤال حنرجع نعيده بعدين. اذا بدك نرجع نعيده بعدين. ظهر 2 ظهر 3 فات 10 حنشوفهم كل الاحتمالات بس مش بهيك كويشن بس مش كافي لحالها. هيدي بارت اوف هيدي حتكون بارت اوف اوكي. وضحت؟ اوكي. Another question. What is the probability a new customer only one customer what is the probability a new customer will arrive between 11:28 and 11:30 given that the last customer arrived at 11:25. So here we have independent events okay. Focus on the date. So what is the probability new customers arrive at 11:28 minus 11:30. We have here also 2 minutes. Given that last customers arrived at 11:25 a.m. So we draw the timeline. So before 11:25, okay, the last customers arrived here. So between 11:25 and 11:28, no customers. And between 28 and 30, we need to calculate what is the probability to get one only customers in these 2 minutes. So 3 minutes, no entrance of any customers. Then 2 minutes, probability to get one customer. So we have here 2 independent events okay, 2 interval of time. So we calculate the 2 probability here. Probability of no customers in 3 minutes times probability of 2 customers in 2 minutes. You got it? You got this? We have 2 independent events. 3 minutes without customers, what is the probability? And times, okay, and times probability to get only 1 customers in these 2 minutes. So probability to get 1 customers between 28:30 and, which means times, probability to get 0 customers between 25:28. So we multiply the product. The probability. So probability of 2 minutes for 1 customer times probability of 3 minutes for 0 customers. So here, t equal 2 minutes and k equal 1. Here, k equal 3 minutes, sorry, t equal 3 minutes, time equal 3 minutes, and k equal to 0. So direct connection here. We implement this for t and k, this equation, to given that this number. Okay? Okay? Any question here?
لا واضح.
وضحت؟ بعدنا عم نحكي arrival. So the Poisson distribution in the queuing system will calculate only the probability of arrival customers, not exit, arrive. Okay, not exit. In exit we have another probability. Okay, later we'll see it. Any question for here? Okay. Now we start to finish end of chapter 2. Okay. Any question?
دكتور
تفضلي.
هلا نحن اول السؤال هن قالوا لنا انه احنا عندنا 20 customers per hour average يعني
Yes.
اللامدا هي 20 t مش 20
The same. Lambda the same. Lambda equal 20 customers per hours. Okay. Per hours. You have unit hours. We can write it 20t. Okay.
فنحن استعملناها بال
equation
كل
تحت.
ثاني استعملناها 20 t مش 20
صح.
يعني
صح لانه نحن عندنا minutes هون ما عندنا hours. عندنا minutes. يعني example عندك 20 customers in hours. Okay. Let's say in 5 minutes كم customers بفوت؟ In half hours كم customers بفوت؟ In half hours عم بسألك.
شو؟
عندك 20 customers the rate lambda rate.
يعني 10 بنص ساعة.
حسبتي ال 10
20 times half.
كيف اجت الهاف؟ لانه
أوكي.
ضربناها بالتي.
اوكي.
هذه بسموها ما بعرف بالفرنسي ان فرنش ايكوال راجل دو تروا، بالانجلش ما بعرف شو بسموها. اوكي راجل دو تروا for 20 اوكي for 20 customers for 1 hour. You have here whatever half hour. شو بتساوي هون؟ هيدي ضرب هيدي على هيدي صح؟ هون الاكس شو بتساوي الرقم؟ ما بتعرفوها هيدي راجل دو تروا؟
بلا
اوكي
كريس كراس او
Yes.
كريس كراس او شيء
هيدي
هيك يعني.
هي نفسها هيدي ذا سيم هيدي هي. فدغري اختصرناها لانه هن استعملوها دغري 20 تي، فسرتها شوي فوق قبل ما نستعملها بالسوليوشن. فهي تي فور 1 hours اتس لاندا اتس 20 لانه we have rate here. We have rate lambda rate customers per hours it's a rate. Okay, it's a rate. So depend on time the value of 20 will decrease or increase. 2 hours will be 40. Okay, did you get it مريم؟
مش الحال.
Okay, that's why لانه هم استعملوا solution انا جابه من الكتاب. It's a solution from the book. Okay, هاتي بالايكويشن نحن هون ورا بالايكويشن الاساسيه ما حاطين تي. اوكي بس في ايكويشن ثاني بغير محل بحطه هون فانكشن اكس اوف تي بحط التي هون وهون بصير لامدا تي باور اكس اي ماينس لامدا تي اوفر اكس بار بس هم بكون بي اكس تي. like this. لحظة، وين راحت like here fx of t بتساوي هالفورمولا بالاكسبوننشال. فكمان بالبوسون we can write it as like this: probability of x of function t equal lambda and so on. اوكي فهمتيها؟ هون فينا نشتغل هيك px of t function of t equal lambda t power x e minus lambda t over x bar. اوكي اذا بدنا نصلحها قبل ما نطلع لكم اياها هيدي بصلحها انه تنكتب بفورمين، فورم بلا تي، فورم مع تي اذا تي بوزيتيف. اوكي I will add this before uploading. Okay, so I will stop the recording.